Good afternoon, dear participants. Sir, Vignesh, sir, shall we start, sir?
Sure, sir. We can start.
Okay. The introduction, the resource person by Dr. K.S. Moganasundram, Assistant Professor, the Department of Computer Science and Application. Over to you, sir.
Good afternoon to one and all present here. I am Moganasundram, Assistant Professor in Computer Science and Applications, SRM IST, Vadabalni campus. First, I thank our resource person, Engineer G. Vignesh Kumar, for accepting our invitation. Now, I wish to introduce our resource person, Engineer G. Vignesh Kumar, founder and director of SkillKora Labs. He is B graduate from EEE Department of Sri Sangram Engineering College in the year 2018 with University Bank. He is also data science scientist at PRODAPT Solutions, IIT Madras Resource Park. He has more than 3 years of experience in the field of AI. He also worked on telecom-based machine learning projects. He trains students and faculty members of various colleges in the field of AI. His area of specialization is predictive and predictive analytics. Thank you for introducing our chief guest. Thank you once again.
Thank you, sir, for introducing this resource person. Now, Vignesh, sir, over to you, sir.
Sure, sir. Thank you so much. And good afternoon to one and all present here. It's my pleasure to be with you people for this wonderful session on computer vision, NLP, deep learning, image processing, and like various aspects of what we are going to deal with today's session. So let me share the screen and hope my screen is visible.
Sir, visible.
Okay, let me start with presentation. Okay. So about us, thanks for the lovely introduction about me. Quick introduction about SkillKora Labs. SkillKora Labs is a startup which was incorporated with the government of India during the year 2019. What we are doing is that we are imparting technical skills as well as non-technical soft skills to students, job seekers, freshers, working professionals, faculties of various colleges, etc. And then we are involved in providing FDPs, workshops, seminars, then internship to college students, and as well as the faculty members. So this is all about SkillKora, and apart from this, we are in contact with various MNCs and various industries to do real-time projects along with the students. So this is all about SkillKora Labs. We do have a team of 10 plus members, and also faculties from various colleges are a part of advisor for our SkillKora Labs. So this is all about SkillKora Labs. Everyone in this over here, right? So anyone will be working in any of these top 10 technology buzzwords. Hope everyone are aware of at least what they are, right? So basically in this very fast growing culture and in a very fast developing case, we all should be in a place where we are up to date, we are in scope within the market standards, so that we would be on track with our competitors, and also we would be on the finger tips of all the work which we are doing, right? So instead of going on with a very legacy application or a old application or a old technology, working on a old technology, if in case we are updating ourselves and then we are working on the new technology or the new bus things, right? So then it would be very much interesting. So what are the top technologies that is creating a buzz over here in the sense, I mean in the market, in the industry? So are these top technologies like artificial intelligence, cloud computing, or blockchain, or internet of things, or hyper automation? Like automation is something which has become old, but hyper automation and virtual assistants are something which has become the advancement of your automation. So the market is chasing in such a manner that everyone, all the students or all the research fellow or faculty should be aware of, or should be in trend with these technologies, is what the actual expectation of a market in the sense, I mean to the industrial standards. So our today's topic revolve around machine learning, predominantly with respect to image processing, computer vision, and then with respect to deep learning, convolution neural networks. So, as I said before, why is that the market has a very great higher demand for these technologies? So that is the reason we are chasing with all these new technologies. I don't say they are new, but which became very popular in the recent few years. In the few years only, artificial intelligence, wherever you turn, right, people will say, I'm doing a data science course, I'm doing an artificial intelligence based course, something of neural network. So all these are kind of trending topic for the recent last few years. The reason is that in due to the advancement or the growth in the technology, right? People want everything in a very fast manner. You all are aware of the telecom journey, right? So it was in the early 90s where your mobile phones came into picture, like 1990s or 1991. Then it took 20 years for us to sorry, it took around 10 to 15 years for me to move from mobile phone based thing to an Android based thing. So it took those many years. And after which, if you see, right, the advancement, the growth is not in a linear fashion. So the growth was in a exponential fashion. Nowadays, right? Like few years before only we started with 4G, but now in the next 6 months we'll have 5G in place in India itself. And 6G, it is the research is going on in a manner that 6G will come in the next 2 to 3 years. Uh, uh, so uh, so the advancement is of that fashion. The growth, everything in the technology aspects, right? So everything is in an exponential fashion. Why is that need? Is that now the current generation or the current of people like us, right? Though so they want everything to happen in a very fast manner. So if that's the thing, then the inventions across all these technologies will have AI in them, because anything which we do, any manual process we do, right? So everything has to be automated. Than saying it to be automated, if it is a kind of prescriptive or a predictive based approach, then there will be no need for a human to get in picture, and then and then the errors or the bugs or the manual intervention time, everything will get reduced, right? So that is the primary reason why artificial intelligence came into the market, and then it has grown like anything. And people say that in the future, after some 50 to 60 years, normal people will be competing with superhumans. Superhumans are one equipped with all these kind of buzzwords and technologies. So that is how the market actually is as of today.
Excuse me, sir. Vignesh, sir. Dear participants, there's a small issue in the network. So kindly wait. Participants, the attendance link, feedback link for the session also will be posted in the end of the session 2. So kindly wait till the session ends. And in the final, we will have a small photograph session. So kindly wait till 4 p.m. until the session got over. Sir, yes, sir. Vignesh, can you able to hear me? Vignesh Kumar, sir.
Sir, yes, now I'm able to unmute myself.
Okay, sir. Okay, sir. Yes, sir. We can continue, sir.
Sure, sir. I'll share my screen.
Yeah. Yes, sir. It's visible, sir.
Okay, sir. So was it sorry for the inconvenience. Was it this slide which went, or it was a previous slide?
Yes, sir. Actually, from this side, sir.
Okay. So as I was saying, the top technologies like artificial intelligence, machine learning, everything, right? So because of the advancement of the market, right, and also we people wanted everything to be on a very faster fashion. So that is why when we take the telecom journey, right, so it would be of the sort like 2G, the gap between 2G, 3G, 4G, and 5G, it is reducing, and it is in an exponential fashion. So since the demand is also is at a very extreme high situation, people have to upskill themselves in these niche technologies, and then make up things very good. So, and although AI, it is not specific to any domain. Say for example, it is specific only to electrical domain, it is specific only to a medical domain, it is of that sort. Everywhere, any place you can implement AI is basically a luxury as of today, but in the next 10 years, or say it can be even in the next 5 years, it can AI can become as a necessity for us in doing things. So how people do this machine learning and all these things is that there are various tools, there are various programming languages, or there are various packages that is available in the market, through which we'll be able to do our artificial intelligence, machine learning, computer vision, or any kind of AI based activity. But what the market actually does is that it predominantly uses Python as a basic language for all the machine learning activities. Around 70 percentage of the people all over the globe use Python, and then people move on with R, then with SQL, or like Hadoop, your big data ecosystem, or they use Spark computing for a very fast high computational work, and then the rest of the other programming languages. And more specifically, people with electrical background will go with MATLAB as the tool to do all their computation and everything. So since we are since most of the people would be from an computer science background, we'll prefer Python for today's session. And the reasons for people using Python is that it is more easy, user friendly, and there is a very good extensive support community for Python. Now we'll move on to all these three different buzz words like the AI, ML, or deep learning. So what actually is AI? AI is a wide range in computer science, and as I said before, it is not only to computer science but also to all the other departments, where the system it itself is capable of performing any activity which will avoid the human interference. So how do they do is that there are two major approaches in artificial intelligence. One is by providing training to the system, making it understand the historical pattern, and then decide the outcome based on the pattern. else. Second aspect would be kind of you giving certain rules, or you give a framework for the system to follow, and based on those set of rules or the framework which we give, the system will make its own decisions. So that is how an artificial intelligence system work in current in today's market level. And what machine learning is? Machine learning is a subset of artificial intelligence where you will train the system, where the training will happen based on the type of data which we give. The data can be of image format, it can be of an audio format, it can be of a video format, it can be of a text format, it can be numbers, it can be anything. Okay, so this particular historical information of any format will be given as input to the system for it to understand, for it to learn, for it to make decisions based on the learning which it is making. And deep learning, again, it is a subset of machine learning and artificial intelligence, where deep learning will follow the same kind of pattern what machine learning does. But the way it is learning will be different when compared with a machine learning application. So when you take a deep learning will predominantly follow the concept of neurons, which is nothing but our nerve cells, right? So how does a human brain work is the conceptualization for any deep learning related project. So this is all about the overview about artificial intelligence, machine learning, and deep learning. Now, this slide will explain you like what is the major difference between artificial intelligence and machine learning. So, as majority of points were covered during the previous slide itself, I'll just give a very quick overview about this slide. So, as I said, artificial intelligence is the superset, or it's kind of the above layer of your machine learning, where machine learning will help, where machine learning is a subset of AI, and it will involve in learning the knowledge, or it will involve the process of learning the pattern. And in artificial intelligence, we will not think about how accurate our model is, or how accurate the system is. But in machine learning, we will see the accuracy, and we will not care how far the system is success. So that is the major difference between artificial intelligence and machine learning. And as I said you before, artificial intelligence can be classified into to the two major umbrellas, like taking a decision or making it to learn. So machine learning is purely taking the decision based on the learning, but artificial intelligence is a combination of both your rule based as well as your learning based. Okay, so this is the primary difference between AI and ML. Now, about computer vision and NLP. So the initial few slides will cover an overview about computer vision and image processing. And then we will move on to convolution neural network. So how do a convolution neural network work? And after that, we will go on with a use case discussion. So one thing what I'll do over here is that let me share a link with you all. So that link as the data set which we are going to discuss now. So people, if it is possible, please download the data set and keep it ready so that you can work along with me on a parallel way. All the code which we are going to discuss, everything is available in that drive link which I have shared you now. So please, if possible, download it. If in case you do have theoretical knowledge about all these technologies and all these terminologies, then it would be easy for you to directly jump in and work along with me in the upcoming hours. So What is actually computer vision? Computer vision is again a subset of artificial intelligence, and NLP is also a subset of artificial intelligence and machine learning. Okay, so what this computer vision is, like, it predominantly works on images. Images in the sense it can be of picture format, or it can be of a video format. At the end of the day, what is actually a video is, it is nothing but the combination of multiple frames, multiple pictures. When they are moved at very faster speed, it forms a video, right? So that's how your video would be. And your computer vision, basically it will work on the images, like processing on the images, converting the images from one form to another form, then making predictions based on those images. And how do video based application work is that this video will be converted into multiple images, or basically to the correct word would be multiple frames. And from those frames, the next set of approach, like either doing training on the data, or you apply some transformations on the data. So all those things will happen on the frame, and your end goal of your application can be met. What is NLP? NLP is nothing but your natural language programming, which involves your chatbot, your voice bot, your recommendation engines, or all your Alexa, OK Google, Hey Siri, everything, right? Everything is nothing but your NLP based approach. So it is very much interesting topic, but that is out of scope for our discussion for today. Probably on some other session, we can discuss on NLP based approaches too. Now, we'll deep dive into computer vision and image processing. So, it was from the early days itself, like say some 20 to 30 years before itself, when you go to a Photoshop photo studio, you would see that like the people would have worked on, and they have put their artworks, like converting a black and white image to colored image, or like restoring a very damaged image, and restoring to good form. So all those kinds of activity a photo studio would have done, right? All your photo morphings and everything, photo studio would have done from those days itself. Say some 20 to 30 years before itself, they started working on this. How all these things work? It is basically mathematics which will revolve around all these activity, to say then what makes computer vision more different from this actual or traditional image processing is that from those image processing, the computer vision system will be able to work on with the algorithms, and it will be able to solve certain things, or it will be able to provide you insights, or it will be able to give you some output, or a kind of decision. So that is the major difference between your computer vision application or an image processing application. Now, let me take an example of this object detection. So when we take the example of this object detection, you see over here, here what happened is that the system was able to identify that this is a cat, and this is something a single object detection, and also you do have multiple object detections. So nowadays, right, when we take our mobile phone, when we take a selfie, or when we take some picture, right, yeah, the system, your mobile phone will have the ability to say that it will detect human face recognition will happen. And nowadays, right, all your selfies which you take, it will say that your what is your age, whether it's a female or a male is taking the photo, and everything, it would be listed. right? How all those things are working. So it looked very interesting, right? When the system is able to say that your age is 25 and you're a male. The system, we didn't give anything as an input to the mobile phone, but mobile phone camera was able to detect that particular things. How all these things happen is purely a computer vision based task. Uh, so uh, so, it is actually the most important and interesting topic. How that will happen is that there would be a code that would read this image, and this image would be converted into pixels. Your pixels would be converted into binaries, zeros and ones, and then from those binaries, zeros and ones, your system will do a classification, saying whether it is a male or it is a female, and what is the age. Okay, so or if you take this example, the object detection, it will be able to detect each and every object, and then it will be able to say about each and every object in that particular image. Say for example, here if you see, while it is detecting red, the cats are detected as red, and the dog is detected in blue, and duck as green, right? So that is how your multiple object detection work. And in the upcoming time, I will showcase you how your logic will be in this particular task. So for that, what I'll do is that, let me open. Okay. Actually, this is a work that has been done by a professor. So it is their activity. So this activity will say like how image or object detection will work actually. How a image or an object detection work. So basically, to be more clear, right? Any image you take, a black and white image, or you take a colored image, it will be in terms of pixels. Okay, so it would be in terms of pixels. Pixels are nothing but I can showcase you with this particular information. It will be in terms of this format only, zeros and ones. So, if it is a black and white image, it would be on the range of 0 to 255, where 0 to 255 will be in terms of your white to black, in terms of your shades of your black. Okay, and when you go with a colored image, it would be a three-dimensional figure, combination of your RGB, where each and every layer will have 0 to 255, 0 to 255, 0 to 255, 0 to 255 RGB. Okay, so any image you have, it would be converted into a pixel of this format, and from that pixel you will have multiple layers, and those multiple layers will constitute and finally will lead to your prediction actually. So I'll again come back to this particular page, because while going on with the CNN architecture and explaining the different layers of an convolution neural network, that slide will help us more. Okay, so as I said before, your deep learning frameworks, everything, it will deal with all your object detection and your semantic analysis or your image classification, everything. So here there is a set of like frameworks or kind of techniques that can be made use for your deep learning activity for your image related use cases. Okay, so the next thing is that, as I said you before, like when you go to a Photoshop, right, photo studio, basically they will do all the image related transformation and with you, right? So basically here you do this is a kind of that example. But how this works is that everything would be in terms of your binaries, zeros and ones. So there would be a mathematical operation that will happen between the pixels of this image and this image, and the resultant is nothing but the end goal of these two images. this neural style transfer, right? So this pixel and this pixel, there would happen a binary operation, and based on that binary operation, it can be either AND operation, OR operation, XOR, NOR, any operation. Okay, so it is our own wish. Whatever style we want, we can provide that as an input to the system, and based on which the transfer or the conversion from one form to the other form can happen. And then you see the image restorations and all the different techniques which people do nowadays, right? So everything is purely based on the initial pre-processing techniques that we follow for any image related activity. So if you see over here, right, so this image is corrupted, it has some kind of white marks over here, but it has been converted into a proper fashion over here. So this technique is called as inpainting, where you will be able to say the system that at this place this was actually the thing that has to come. So all those things can be made, and all your corrupted images can be changed, and resolution or the quality can be improved. And say for example, here you have something called as a text over person's face, right? So those things also can be removed. So how that can be removed is that the pixels or the system would be trained in such a fashion that you have to remove this pixel, or you will apply some filter map or a feature map above your actual image, and through which the image can be restored. And again, the same example which I said before, like applying a layer of another combination, a kind of another logic map between your black and white image, you can restore and you can make the system into a color image. And again, there are various resolution techniques that you can follow, and then through that resolution techniques, you can apply those filters to your actual image, and then the image can be restored. So when you take your mobile, again I'll take your mobile phone as an example. Nowadays you will have your portrait mode in your camera, right? So how does that work is that it will check for the person, and after the machine learning system says that this is the person, it will try to get the pixel or the density of that person, and based on which the rest of the places would be blurred. So that's how your image resolution or making your portrait images, everything will happen. Then and this is a kind of technique called as for image synthesis, where you make combination of both the things. It is again what you do is that you apply a filter on one image and the other. Like if you see over here, right, actually it is a zebra, but you converted it to look like an horse, and this horse you have converted to look like an zebra. So all these kinds of synthesis are nothing but applying a filter on one image and the other image. Okay, so by changing your combination of your RGB, your image synthesis can be performed. And then all these things, right, so are something additional thing which I wanted to showcase you. Now I'll move on to the actual and the most important topic, like how all these things are happening. Now till now we have seen what are the different applications of image processing, and what are the different ways of making some restorations or kind of processing that we act on the image, right? How this is happening is that there are various ways, like going on with a convolution neural network, or going on with a kind of rule based thing, or kind of some kind of tools also can be made use to do all your image alterations or image transformations. So if you go with a tool based, then it would be in terms of your artificial intelligence, it will not come under the sector of your machine learning. When you want to go ahead with a machine learning and a deep learning based approach, then you go with a neural network or some other machine learning algorithms, which you will convert the image in terms of your numericals or numbers. Than saying in terms of numbers, you will convert it in terms of binaries, zeros and ones, and from there you will be giving it as an input to the machine learning model or a neural network layer, and from there the system will be able to identify and then make a classification. So these are the different layers in a convolution neural network. Predominantly you will have your input image. Input image, as I said, it can be black and white or color and color image. So depending on black and white or color image, your either black shade or your RGB shade will happen, and upon which what you do is that you will convert that particular image into this format. This format is nothing but the binary. So every image, when you zoom right, at the end of the day, your image would be in terms of pixels. Pixels in the sense a kind of square box, right? So whenever you take an image, you say the resolution is 1080 into 1080. It means that you have those many pixels in your image actually. Like, or you say it is 720 into 480. Then when you multiply that, then at the end of the day, you will have those many pixels in your image. Or if you say it is a 4x4 image, then if you will have 16 pixels in it. 16 pixels are nothing but 16 data points will be available to that input image. And to this input image, if you want to make some alterations, what you do is that you will have all these feature detectors, feature map, and this modifier. So again, it is nothing but a kind of binary, or it would be a kind of zeros and ones. From those zeros and ones, you apply your mathematical function on this particular input image, and then you will convert this single input image into multiple convolution layers. Okay, so from this convolution layers, again you will reduce the size of the convolution layer by applying certain functions, certain ReLU functions or certain activation functions you will apply on it, and then you will reduce. It is nothing but your dimensionality reduction that will happen from your convolution layer to your pooling layer, and this is a single flow. You can have multiple flows or multiple combinations, like one convolution layer, one pooling layer. Again, you bring in a convolution layer to this pooling layer, and then you bring again a pooling layer. It can be of any sort. So at the end of the day, your three-dimensional image would be converted into a single dimension. So from that single dimension, you can have multiple hidden layers. So those hidden layers are nothing but basically each and every layer will learn about that particular image, and after it is learning about particular image, it finally at the end of the day you will have the output layer. Through that output layer, your system will be able to say whether it is a dog, whether it is a cat, or whether it is a duck, or if you take it to be any image identification, right? So all that thing can be obtained, or the end result can be obtained at the output layer. So this is a theoretical aspect, and now what I'll do is that I'll again go back to this particular thing, and now I can showcase you what is a convolution layer, what is the pooling layer, and what is a flattened layer, what is a hidden layer, and what is the output layer. Okay, so this is your actual image, right? This is your actual image. This particular image have converted in terms of pixels. See, it has converted in terms of pixels. So pixels are nothing but your square box. So everything is nothing but 0 and 1. So instead of saying it to be 0 and 1, it is in shade of 0 to 55, depending on the color of the image. So each and every place, right, you apply certain filters or you apply certain feature map on this particular image. And after applying certain mathematical functions on this particular image, this is your convolution layer. So your convolution layer, there can be two possibilities. You can have reduced number of dimensions when compared to your convolution layer, or what you can do is that you can have the same number of pixels or density of your input image or the image from the previous layer. Okay, so what I go is that I will take this place. So if you see over here, this particular pixel, this one particular pixel, it has been obtained from these pixels. You can see the arrow, right? So each and every pixel is obtained from by applying a feature map on all these different pixels. So by applying a feature map, this reduced convolution layer has been brought. And again, what we do is that we are reducing this convolution layer to a pooled layer. Pooled layer is nothing but the furthermost dimensionality reduction of your convolution layer is nothing but your pooled layer. So if you take a pooled layer, so this pooled layer is also having a contribution from multiple pixels of the convolution layer. At the end of the day, this particular input image is converted into a convolution layer, and from this convolution layer, again you are converting it to a pool layer. And you see, this pool layer is again converted into a convolution layer. Now, when you take in terms of this convolution layer, it is a combination from multiple pooled layers. You see, this particular pixel is a combination from this first, second, third, fifth, sorry, not fifth, this sixth. All these six convolution units combine together in order to form this particular convolution layer. And to this convolution layer, what you do, you again apply the pooling. After you apply the pooling, the dimension of your image has been again reduced further. So if you take this particular image, again it is able to again it is able to get the pixels or a combination from multiple pixels of your second convolution layer, and from that convolution layer you are having this particular pooled layer, or your instead of the other word for your pooled layer would be your downsampled layer. Okay, so this particular pooled layer is then flattened. Flattening happens. You see, this is say there are 20 pixels over here. It is a 4x5 image. That 4x5 image is then converted into a single dimensioned flattened layer. So this flattened layer is again combination of multiple pooled images, and again this flattened image will be this particular yellow colored layer. Okay, so this will be this particular layer. Again, you, as I said you before, you can have any number of hidden layers between your output feature and your input feature, is what I said earlier. In this explanation, what the professor has made is that there is one hidden layer, and based on that one hidden layer, you have this output layer. And over here, the output is in terms of 0 to 9. Only 10 different classes are possible for this particular use case. And what this professor has made is that they have drawn this particular use case only for numericals 0 to 9. It will but this is just an example, or this is a way to showcase how your image is able to get classified. So this how your convolution neural network works, and this is an example of a way how your image are being classified. So similar way, if it is object, again the object detection will happen. So based on there would be various training given to the model, since this model is being trained with various different aspects of writing two, various different aspects of writing one, or any of your numericals, right? So based on that only this particular system has been built. We can build any such system in our real-time use case. So what I'll do is that I will even put this particular link for the better understanding about the different convolution layers that works, and what is the math that is behind the working of your convolution layer. So now I'll pause over here, and if in case there are any questions, you can unmute yourself or you can put over the chat. I'll be happy to answer, and then we'll move on to the real-time use cases for discussion. If in case something is unclear, please let me know. I'll clear it now itself, because this is the theoretical aspects of your convolution neural network, everything.
Dear participants, now the chat box is open to you. If you have any doubts, you can put it in the chat box.
Is the pace fine? Am I going very fast or it is slow? You can also put those kind of feedback, based on which we'll take the next 1 hour.
Participants, if you have any doubts, you can put it in the chat box. The chat box is open to you. Sir, shall we have a small minutes of break, sir?
Sure, sir.
Okay, sir. So, participants, now the time is 2:50. You can have a small 5 minutes of break, and you can join at 55, 2:55, 2:57 p.m. Participants, feedback link will be posted at the end of the session. As participants, our resource person came. Vignesh sir. Vignesh Kumar.
Yeah, yes, sir.
Okay. So, sir, shall we start, sir? Before that, actually, in our chat, some of the participants have asked doubts, sir.
Sure, sir. We can go ahead with those clarification. So I would see that the very first question was, can we use heart disease for prediction? So to answer that particular question, if the input data set is of the format of image, say for example, you are taking the angio images of heart, then it is pretty much easy for us to directly use that particular image, train the neural network, and then based on which we'll be able to do the predictions. And if the input image is I mean, if the input data is of not an image format, if it is of in terms of your numericals, say for example, what is the pulse rate, and say, or what is any of the other inflow of blood to your heart, and what is the outflow, how much it is pumping out. So all those things, if we are able to measure and we record it in terms of a table or a CSV file, then that can also be given as an input to your system to find the prediction. And it depends on use case to use case, sir. So that is about uh, that question. And any new deep learning algorithm for image segmentation? So for any image segmentation, the predominantly most used algorithm would be CNN. But any image that is vectorized can be used by any of the other ML or deep learning algorithms. You can use autoencoders, you can use SVM, or any kind of clustering algorithms, or any kind of classification algorithms can be made used for any of the application. There is no specific thing, just the input has to be in a format the algorithm accepts. So any algorithm can be used, sir. And okay, so I find these two questions over the chat. So any more questions, please feel free to put over the chat. Now the next 1 hour of the session would be, I'll share my screen. Okay, so the next 1 hour, it will deal with three different use cases. One would be a basic convolution neural network, like how do a convolution neural network will be able to, I mean, predict whether the image is a cat or whether it is a dog. Okay, so that would be our very first use case. So now I'll showcase you the data set. Okay, so for any image related use case, right? So you should have the folder structure well in place. So the folder structure is most important for any use case with this related to an image processing. So the very first thing over here is that the first use case is predicting whether the image is cat or dog. Okay, so that would be the first use case. So the training set has two classifications. So this classification has n number of images. Around 4,000 images are available over here. If you see, 4,000 different cat pictures are available. So along with this cat, right, there are various outliers also. Like, see, if you take this particular cat now, it has a name board with it. It has some kind of cage with it. And if you take this cat now, so along with the cat, you have this particular place where it stays. Or if you see for this cat, it is a behind of fur. And like, you take any other cat, right? This is something multiple cats in a cardboard, and there is a glass over here, right? So like this, there are various combinations. Even if you take this particular image, right, along with the cat, there is a person sitting with the cat. Now, so all these act as a input image or the training data set, through which you will be saying any image of this format will be a cat. Okay, and then we do have again the data set for dogs. Again, you will be saying these are the different dog images that are available, and you will be giving it as a training data set to your convolution neural network model. Okay, and after which, what you do is that you will train, you will do your testing. Testing is nothing but your validation. So with 1,000 records, I'm doing my validation, and after which I'll also give certain predictions for my data set. Okay, so so there are two ways participants one kind of information. There are two ways through which you can work along with me in this parallel working session. One, you can make use of Google Colab, or if you have your local system installed with the Jupyter Notebook. So Jupyter Notebook is a tool which we will be using for our Python use cases or any machine learning or deep learning use case, right? So we'll be using Jupyter Notebook. So what you can do is that I have already shared the drive link which contains all the data set and which contains all these codes. Okay, so you can directly make use of that code, and if you open it in Google Colab, you have to include these two things in your Google Colab. Like, you have to connect your Google Colab with the drive, and then drive which place you have your information, right? So do a change of directory to that, and then your Google Colab will have all your TensorFlow, Keras, or any deep learning algorithms, right? Though they would have been made readily available in your Google Colab, you can directly use it. Currently, for this demo, I'm using my local PC. So in my local PC, I have TensorFlow installed. So if in case you don't have TensorFlow installed in your system, you can directly do a pip install of TensorFlow in your system, and then from there you can take your uh, use case. Okay, so even before that, if in case you don't know what this tool is Jupyter Notebook, which is predominantly used for any real-time coding and presentation. Okay, so this is a Python interface. So if you want this also to be installed, you should install it through Anaconda Navigator. Okay, so this Anaconda Navigator is there, right? So this is a particular tool which we'll be using. So in this you have your Jupyter Notebook. So I will even share that particular link over here. You can download it. You can download and try with your use cases. Okay, I'll move on to the data set. As I showed you before, we have this training and we have this test data set. So any data you take, you cannot directly give for training. There should be certain components, or there should be certain hyperparameters that has to be tuned for the data, and that image has to be converted into input image. Input image is nothing but binaries, okay, zeros and ones, or it can be 0 to 255 in terms of your black shades, or it can be of your combination of your RGB combination. Okay, so this particular image data generator is a function that is available in TensorFlow and Keras, and that you would have imported from the pre-processing place of your Keras. Okay, that will reshape your pixels in terms of zeros and ones. And apart from that, there is also sharing and zoom range that you will apply to your data. So why do you apply all this share and zoom to your data? Is that major reason is that when you work on a real-time use case, you cannot justify that you will get the proper image. There can be any scenarios. So that is a major reason you are imputing certain loss functions, or you are imputing some additional external bad vibrance or resonance to your image, and make that particular image suitable for your real-time data. Okay, so that is the thing you're doing over here. And this data gen, this particular thing, what you are doing is that from this particular directory, what you make is you convert all your images into 64 cross 64, and you put it into this training data set. So now this is saying that it has found 210 images belonging to the class, having two classes. Two classes is nothing but dog and cat over our use case. Right? So this is how you are preparing your training data set. And same way, you have to prepare your test data set. Okay, so after you have your test and your training data set, what we are going to do is that we are going to build a convolution neural network. So as I said you before, like the different layers which you will have is your first convolution layer, and after your convolution layer you will have your pooling layer, after which you can again have certain convolution and pooling layer. It is your wish. It is your wish. You can have any number of convolution layers and pooling layers, but it is necessary for us. It is not necessary. We say it to be as a good practice to have at least two different combinations of convolution as well as pooled layers. Okay. So there are certain various activation functions which there are multiple activation functions to your Keras functions. So you can Google and understand those different activation functions. Okay, so now after we have that input layer, right? What I make it, I flatten the pooling layer. After the code to flatten this, after we flatten this, what I do is that I have multiple hidden layers. Here in this use case, I have used only one hidden layer, but you can have multiple hidden layers. Okay, if you want to add one more hidden layer, what you do is that you just put over here the same code. Okay, so it means that again hidden layer would be found. In here you can have multiple units. Okay, so if you would have seen, right, so in the PPT there are multiple units. It is your wish, you give the number of units, but see to that when you overtrain your model to a specific use case, it will actually lead to a thing called as overfitting. Okay, so there is a concept called as overfitting in your artificial intelligence and machine learning space. So when you fit a model or an algorithm specific to that data set, training data set, then it may not perform well in your real-time scenarios. So we should avoid overfitting. And there is also another case called as underfitting. Underfitting is something which you will not do proper training of your data set. So in real time, it will not perform well. Okay, after which you will have your output layer. So this output layer will have your final output saying a prediction. A prediction is would be of two sorts. Either it would be of dog or it can be cat, right? So after you add all these different layers to your model for your algorithms object, you have to compile it and you have to form it into a single stack. You have to compile it and you have to form it into a single stack. All these time, right? So building the CNN, everything is nothing but you were creating the skeleton for it. You didn't train it. You just created a skeleton for it with multiple different layers, and then you are compiling it and having it stored as a CNN object. Okay. Now what you do is that you are going to fit the model with your training data set, and the validation will be done with your test data set. Okay, so for this particular neural network layer, what you are going to do is that you are going to fit, actually you are going to train the basic terminology that we are going to use is you are going to train and you are going to evaluate it with the test data set. Okay, so there's a thing called as epoch, and epoch is nothing but a batch. In one batch, how many runs, how many things you are going to train. Okay, so there are 20 epochs for this particular this particular application which I'm showing now. Is your interest. If you have a very good GPU, if you have a very good computational system, go ahead with any number of epochs. But see to that you don't give some very big number, like giving 100 epochs, 1000 epochs, 2000 epochs. It is not necessary. Okay, if you go with more number of epochs, or if the epochs number is higher, right, at the end of the day, it will lead to overfitting. If your data set is very large, say for example, you have a million of images, then your epoch has to be higher. I don't say it is wrong. Okay, but if you don't have that much data, have your epoch very less. Okay, so for this epoch, for this particular use case, I've given 20 epochs. What you do is that do the same algorithm with a different number of epochs. Say for example, you give some 30 epochs. See how what would be your final accuracy. Okay, validation accuracy. What is your actual accuracy? Like that. Give some less number of epochs and try to run it. Check the validation, and finally you come to a conclusion on choosing the number of epochs for a particular use case. Okay, so currently what I have given is 20 epochs, and at each and every epoch you will take some time for the model to get trained, or the model to pass on through all these different layers. Okay, so when you pass on the model to all these layers, right, so one batch would be trained, again the next batch, again the next batch, like this. There were 20 batches that was trained on the same object, on the same neural network. 20 different iterations has been made. So at each and every stage of your iteration, you could see that there's a loss function as well as there is your accuracy. This loss and accuracy is for your training data set, and this is for your validation data set. Okay, and the time taken for each and every epoch has been recorded over here, and for each and every step you could see each and every step, in the sense there are two 251 steps in this. In this 251 steps, for each and every step, it took time. So it took 256 seconds for your this single efforts to run. Okay, and the accuracy was 67%. And the next stage, right, when the next efforts was run, since already there was a training made, your accuracy has increased from 67, it has increased to 72%. And also the time taken for this particular step movement has decreased. Okay, has decreased. And I don't say you that in all the steps you will have a decreased fashion. In certain stages you can have certain variation, like it can take some more higher time. It depends on your computation bandwidth of your system. Okay, if you have a lower configuration system, then again it will not your it will take more time. And if your data set is higher, again it will take time. Okay, so based on which your validation and your thing happens. And there is one more function called a summary. When you give to your model, right, your sequential, I mean, the object of your algorithm which has been made, right, it will give you a summary like what is a convolution layer, what is a max pooling layer, and what was the shape. Okay, what was the shape of each and every layer. Everything will be mentioned over here. Okay, what was the input parameters that was passed to this, and what was the output parameter, and what happened, everything will be explained in a detailed fashion. Okay, so what are the total number of parameters, and what was the training and non-trainable parameters, everything will be given as a summary when you make use of this particular function. All these things, when you say for example you are presenting some journal or you're doing some paper presentation, all these things are the most important questions which jury will ask. Because when you have multiple summaries of this format, right, you can showcase them the comparison between multiple models. The summary is more important when you go with multi-model training and all. Okay, so after which now what I do is that I will make a prediction. Okay, we made the training. Our end goal is to say whether the image given is dog or cat. Okay, so now what I do is that I will again take that image, same pre-processing has to happen on that image also. See, so the training has been done on a 64 cross 64 image, right? Then the test, your prediction image also should have 64 cross 64. So what you do is that you have your data set. So probably I can show you. This is a single prediction place. So a cat or dog underscore 1 is a dog, and cat or dog underscore 2 is a cat. So if you see over here, right, so I'm giving cat or dog underscore 2 as an input. Now I will run this particular thing. So after I run it, if my result is 1, then I say to be a dog. If my result is 0, I say to be a cat. Okay, now if I print over here, see, it is saying cat. Now what I'll do is that let me change the validation over here. Instead of which, let me run with the first image. You see, it is able to predict it is a dog. So this how your convolution neural network works, and this is how it is learning and it is able to identify. The primary part works on we creating the data set in a proper fashion. Okay, so it is our duty to place the image in a proper folder structure. After we place the folder structure, we apply certain functions. We pre-process the image, both the test and the training images. Then we build the layer, we compile it, we train the layer, I mean the neural network, and we do the prediction. Okay, so this is a very simple use case which I have brought in front of you for your understanding. So this can be implemented for any use case, any image use case. And the next two use cases which we are going to see is about diabetic retinopathy, and the other would be detecting the COVID image, I mean from the X-ray image to detect whether it is COVID or pneumonia or a common cold. Okay, so now I'll pause. Any doubts till now? please let me know or raise your concern, so that we'll clear it then and there. And then when you go with the other real-time use cases, it would be pretty much straightforward for you guys to understand. So participants, please let me know if in case you have any doubt. Okay, so this will be the base of any convolution neural network. And again, see, as I said you guys before, that convolution neural network alone is not the approach. Okay, you do have your visual geometry groups, which will have different combinations of your this convolution neural network. Okay, so it can be of any fashion. Okay, ResNet or your VGG net, anything, any technique can be followed. Like for one of our use case, we'll be using this VGG net only. Okay. So participants, any doubts? Okay. Let me take. Okay. Okay. Thanks for the response. Let me continue with the next use case. So the next use case would be on diabetic retinopathy. Okay. So we all know that when a person is affected by diabetes, most probably they will say that a person who is affected by diabetic, right? So they'll have many issues with respect to their eye, or with respect to their kidney, or with respect to their leg. So these are, or with respect to your heart. So these are the most important places where the person who is affected by diabetes, right? So these are the most important parts of your body which will get affected. So everyone are aware of this diabetes. So diabetic retinopathy is the loss of vision or your blurriness of your vision, which happens due to the blockages that happen because of diabetes on your retina. Okay, so how it is being identified is that by taking the images of your retina, doctor would be able to say that you are affected by diabetic retinopathy or not. And more crisp and clear, there are multiple stages of diabetic retinopathy: severe, mild, or more severe, like the worst case. Like you will have different stages in your diabetic retinopathy. And what this real time people they do is that with the help of this diabetic retinopathy use case, the doctors can make their own decisions, like whether to go for an operation or not, whether what sort of treatment can be provided for that particular patient. The system will say depending on the retina image. Okay, so this particular use case, diabetic retinopathy, as I said you before, this is the normal retina, and this is a diabetic retinopathy affected retina. If you see over here, right, you have this retinal nerves, right? So there would be some kind of lumps, or that can be of kind of blockage, or there can be of a kind of clot that will happen on these nerves, the retinal nerves. Okay, so those are nothing but your blood carrying veins and nerves, right? So uh, at that place you will have the problem, and there would be a pulling of your retina from your actual position in your eye also. So that's how people detect a diabetic retinopathy or not. So with respect to that, what I'll do is that I'll showcase you the different data which is used for this particular diabetic retinopathy. Okay, so again, see, you have diabetic retinopathy or not diabetic retinopathy, and again, this particular is the Gaussian image of your retina. This is your training data set, and there should be that has to be made on this particular image, whether we say be of what class it belongs to. Okay, so what I'll do is that, see, this is the actual final preparation that I have made for the data set, whether it is mild or whether it is moderate or it is not diabetic retinopathy. Okay, or it is furthermore next stage less than your more than your moderate but less than your severe, you call to be as your proliferate case of your diabetic retinopathy. So that scenario is also placed over here, and then finally you have your severe scenario. Okay, so this is your severe scenario. So if you take the image of those retina, right? So it would be very much severe. Like these are your veins, right? So you could see that there are many blockages across each and every vein, and then the retina's position has been pulled. Actually, the nerve, your optical fiber will be over here, right? So it has been pulled from the actual center point, everything. So so this is your sample data set. Okay, so now let me go on with the coding aspects, like how it works. Okay, again, here we are using the same TensorFlow as your model input. Okay, so sorry, as your algorithm for your for this particular by your retinopathy classification or not. Okay, so again, what I do is that one important thing that we should take in mind when we do any use case, try to have some aggregations or summary. Okay, try to have certain aggregations or summary with respect to your data set, so that you can do good analysis on the data set. Okay, so after you do good analysis, you'll have the confidence to create a proper model, or you'll have that level of confidence to create a proper neural network or a convolution neural layer. Okay, so this particular train.csv file will have all this column. So for each and every id, if you see, right, so all the images have been put in terms of an id. So with respect to this id, right, what actually was the diagnosis, whether it is diabetic retinopathy or not, and what was the type of diabetic retinopathy or not. Okay, so this is how the classification will be made available. So the next thing is that you can do certain visualizations on top of your data set, and by doing for all these visualizations, right, you can either use Matplotlib, or you can use Seaborn, or you can use Plotly, which can be used for your visualization. Okay, then excuse me. Sorry. So when you do kind of visualization, you will be able to understand that what sort of algorithm can be used for your machine learning application or your deep learning application, and based on which you can decide the hyperparameters also. Okay, so now what I have done is that I am just bringing some statistics, and then I'm creating certain working directory, shuffling my images. So by shuffling my images, the thing would be of random fashion. So by random fashioning, my use case will not be specific to a particular training. Okay, so or it will work for all sort of real-time use cases also. It will not stick to any single use case. Okay, so through which you are creating your train data, validation data, and your test data, and then now you are copying it to uh, I mean, you are copying it to the actual place where you are going to use for your image uh, generation. Okay, now as usual, your image data generator, you are using it in order to say whether how many images you are going to use and how many classes it is going to involve in. Currently, even though we do have various different classifications like moderate, mild, proliferated, or severe, currently I'm going to take into account whether it is a diabetic retinopathy or not. If you want to have it into multiple sections, then you can go ahead with having multiple classes in it and creating your data set or your training folder structure in that particular format. Okay, then since we have gone through the different convolution layers and the pooling layers. Now what I'm going to do is that here, if you see, right, there are three different layers that are three sets of convolution layers. This normalization is again a kind of your value addition to your pooling layer and your convolution layer. That does not there is no greater difference by adding a normalization layer to your actual convolution layer. Then what you do is that you add your dense layer, and your dense layer is nothing but your input layer, your sorry, your hidden layers. So to this hidden layers, finally you are going to have the output layer. Okay, so finally you are compiling it. The same process takes place. You will have certain functions. It can be of your ReLU functions, or it can be of your atom classifier, or your binary cross entropy. Any kind of loss function can be placed, or any kind of optimizers can be made use for your model, and then you can do a training on the data set. Again, if you see over here, I have trained it with 12 epochs. As I said you before, it purely depends on your use case, and it purely depends on your data set. You can have any number of epochs, and it depends on the data, everything. Okay, at each and every time you see, there is some time consumption that is happening, and then there's a loss that will happen at each and every stage. The purpose of your loss is to make your data stick to a real-time scenario, not with respect to your training scenario. Then you have your accuracy, your validations at each and every stage. If you see, by moving my training to the next level, next level, my validation, my accuracy has got increased. The reason why I stopped with 12 is that if you see over here, right, the last three epochs, there is no greater difference between my accuracy, right? So this is 92%, 92.18 percentage, then it is 92.55 percentage, then the again is 92.73 percentage. There is no greater difference. So I could have stopped with 10 epochs itself than going with multiple epochs or multiple runs, right? So I could have stopped. It could have saved me some good revenue, right? When you go kind of implementation with cloud platform, Either you go with GCP or you go with the Azure or you go with the AWS model, right? So when you go with them as your cloud providers for all these things, for using your system, for using all the resources, you will be paying. You will be paying in terms of based on the credits that you consume for your GCP or for your Azure or for your any data lake or a cloud provider, right? So for all, if you want to minimize that cost computing, then again you should wisely choose the hyperparameters. You should choose the you should wisely choose your number of layers and the number of epochs or the batch that will go ahead. Okay, and one more thing that I want to say is that there are various techniques to find the best optimum numbers or hyperparameters, like making use of grid search, CV, or CV. There are various tools which you can use to find the best hyperparameters for your model. Okay, you can make use of that. With that, you will be able to say what can be the best number that suits your real-time use case. Okay, then once again, there is I've evaluated my model. Sorry, I have evaluated my model with my test batch, and then I have checked what would be the accuracy and what is the loss for that particular evaluation, and then I'm going to predict whether it will lie into which class, whether it is diabetic retinopathy or it is into or whether it is into your non-diabetic retinopathy. If you see over here, right, it's in terms of your weights. The previous use case which we discussed, even there I made a if condition stating whether it is 0 0, it is 1, or if it is some other thing, it goes to cat. Similar way, here you have one to be for diabetic retinopathy and one to be for your actual non-diabetic retinopathy. Okay, so based on the combination, actually it is giving you more accurate weights. What you can do is that you can round it off and then you can have it as single figures, saying either it would be into diabetic retinopathy or it could be into non-diabetic retinopathy, and based on which you will be able to predict. This how your data works, and this how use case will flow for any real-time activity. This is how we are doing our classification for diabetic retinopathy. So let me pause here, and if in case anyone has any doubts, please let me know. We'll clear it. And the next use case would be on the COVID data set. So before moving on to that particular use case, I wanted to pause, and I wanted to know whether you guys are able to follow, and then if in case you wanted to ask questions related to your own project, I hope most of you would be doing your real-time projects, right? Your research activities, and you would be doing your thesis activities, everything. So if in case you want to ask any clarifications regarding to that also, the floor is open. You can ask me, and he'll help like how much I can contribute to that also. We can discuss.
Participants, if you have any doubt, you can put it in the box. Yes, participants.
Okay. The best tool for deep learning, MATLAB or TensorFlow? See, uh, basically, MATLAB, who will prefer is that people on electrical and electronics or an electrical and communication background will be the people who will be predominantly using MATLAB. And MATLAB, the thing is that there are less community support, and MATLAB is again a licensed tool. It is not an open source tool. So those are the limitations of using MATLAB. And MATLAB, you will have everything in terms of inbuilt modules. So you directly take those modules, put in place, create a flow diagram, and then with that you will be able to achieve your result. But TensorFlow is something an open source and widely used all over the globe. So it is pretty much easy for anyone to use TensorFlow, and the modifications or fine tunings, it is pretty straightforward in TensorFlow. So I always prefer TensorFlow than MATLAB. And then the next question is, can we use CNN for credit card structure data? Like, could, if it's possible, could you please elaborate like, what actually you mean to that credit card data? Because structured data in the sense, for credit card, we may not have, I mean, uh, we will not have a kind of image related use case, right? So I don't find CNN to play a good role for credit card data, but you can use a normal multi-layer perceptron neural network if in case you want to use deep learning concept. Else, my preference would be go ahead with any machine learning algorithm which does a classification. Or if the end goal or the output of your data would be in terms of, instead of classification, you go with a kind of continuous variable, kind of regression output, then no issues. You can use any machine learning algorithm, either classification or a continuous algorithm can be used. I don't, unless and until you deal with any image related activity, I don't prefer CNN to be the best fit. You can use any multi-layer perceptron neural network, or a basic neural network structure can be used for any other data set than image. Yeah, see, is there any other advanced deep learning algorithm in deep learning apart from CNN? Actually, see, deep learning, CNN is a base algorithm which we'll be using for any image related activity. But yeah, true, there are many algorithms. As I would have shown you earlier before this particular slide, right? So I have said you certain other related tools or a kind of networks that can be made use. So you can make use of any of those algorithm also. It is not advanced for each, for each and every use case. It varies. For a use case, for a simple use case, right? You can have your logistic regression will perform well when you think of using some neural network or any other use case also. It depends on use case to use case, and there is no thing that you say one is better than this. For CNN input layer, can we give matrix format? No, for input layer, it has to be a single flattened layer. Matrix in the sense you mean to a two-dimensional format. No, it is not advisable, or it is not the proper fashion, we give a, matrix format to your input layer. So always when it goes before a input layer, it would be a flattened layer. Okay, so for the credit card thing, it was said that it is a non-image data. As I said before, for non-image data, please go ahead with any other machine learning algorithms or any simple neural network or any other algorithm than CNN. So can you suggest any problem for my MPhil research in computer science? I'll show my contact details. Probably you can directly reach out to me through mobile phone or through email. We can discuss on it. Okay. I hope I have answered the questions which were posted in the chat. If something I would have missed, please you can reach out to me. Okay, so now last I cover the last part of the use case which I had in mind. Okay, so this is with respect to the COVID data, whether it is a pneumonia or it is a normal, I mean, it is not COVID or not pneumonia or it is COVID. So everyone, for the past 2 years, we suffered a lot with all work from home, kind of all lockdowns, everything because of this COVID-19. So it has created an impact on each and every one of us, either in terms of personal loss or in terms of kind of professional loss or in terms of any or the other factor. Each and every one of us would have been affected either physically or mentally, right? So we would have been affected by this COVID. Like initial days, it was very much difficult for people to identify COVID. Like when you take the RT-PCR test, it took a lot of time for the system to understand and to say, give you the test reports, everything. But then after months and months, if you see, right, so the COVID process of identifying the COVID or the different variants of COVID, everything has improved very fast, right? So apart from that, right, even the test results which the government or the lab gives, right, the time has got reduced. Now within 15 minutes you will get your report. You have all your uh, different test kits, everything readily available in the market, whether to say it is a COVID positive or not. But how it was done during the initial phase? To your X-ray images or your CT images. So that was the most important way through which your COVID was identified. And also there were certain scenarios where pneumonia was also there. So pneumonia and COVID has a kind of close resemblance, and based on which people got confused whether it is pneumonia or whether it is COVID. Then there came a clear distinction. So when process of your artificial intelligence, everything came into picture, system was able to easily identify that it is pneumonia and it is not COVID. And if it is COVID, it was easily able to identify that this is COVID and not pneumonia. And also the system was able to easily say it is something like kind of 50 percentage it is severe. Just 20%, it is a mild case of COVID only. No, it is a very severe case of COVID, like that and all, right? So people were able to say how it was. It was just because of this image which is being shown over here. So in the interest of time, let me quickly give you the differentiation, like how do you read this particular image. Okay, so and then I'll move on to the questionnaire sections, because I could see more people having their questions on the chat. So, in interest of time, I'll just quickly walk through about this particular use case alone. A normal chest, you have your black marks and your actually how COVID affects is that you have your lungs, right? Actually, at the end of the day, you take your lung image, right? So it is it would be like kind of small blobs, or it can be kind of bulb like projections called as your alveoli or your alveoles. Okay, so that would actually at the end of the day it is nothing but those thing which form as your lung, right? So if the COVID is you're being affected by COVID, and the COVID yeah, virus will create a layer above your lung cells, and then it will create a blockage. It will not make you easily breathe, or the oxygen supply to that particular part of your lung will be reduced. Then you will have some breathing issues. In severe cases, people may lose their life because they don't have a proper oxygen supply to them. Then people die. So this how COVID was in the recent times, and nowadays COVID is of not that bigger virulence, but then it is safe that we understand how COVID was, right? So when you take the CT or the X-ray images, right, you see the lung part. You are not able to see the lung part in a proper fashion. Majority of your lung was affected. But in case of your pneumonia or in terms of your normal lung, right? So it looked normal. The difference when you see at a normal and a viral pneumonia image, right? So it is kind of a bit different. Just a heart alone is visible in your heart alone is visible in your normal COVID X-ray, normal CT X-ray chest report. But in a viral pneumonia, you could see that there are furthermore places where the darkness is reduced, and then the COVID it is much more worse. So through this way, you will be able to figure out whether it is COVID, viral pneumonia, or a normal thing. Again, you do a pre-processing, have your data set well in place, then you apply certain functions to your data set. Then what you do is that you will say whether it is COVID or not. And one more thing which I wanted to say is that here you will be using your VGG. VGG is nothing but your visual geometry group. It is a combination of 16 different layers. So if you see over here, right, it forms your input layer. You have back-to-back two convolution layers. Then you have your max pooling layer, again your convolution layer, again your convolution layer. Like this, you have multiple combinations, to which you will finally flatten your layer, flatten the layer, make it in terms of your output layer. Okay, so actually I rust it up like anything. So finally you will have your dense layer, which will be your output layer for this particular use case. Okay, then applying all your optimizers and your loss functions to your model, you will be able to train your model. So actually the reason why I stopped this particular model to run is that actually I interrupted it. The reason is that that was the reason it threw me out of the Zoom meeting. The system got crashed. Okay, that's why I stopped this particular evaluation. The rest of the other evaluation techniques is as same as the other use cases. Okay, so I have shared all the data with you over over in the I mean in the drive link which I have shared, and this is my contact details. So if in case anyone want to reach out to me, speak about your use case, or you wanted to organize any kind of professional training for your college, or any kind of industrial connect is needed, or any internship is needed for your students, or for faculties also for their thesis or for their professional activity, if you need some kind of support, please feel free to reach out to us. We'll be available over mail or over phone, so you can reach out to us. Now, with this, I stop with my session, and if in case if anyone needs, please feel free to ask me your questions. I'll be happy to answer. And last but not least, I should thank the faculty members of SRM College for giving me a very good opportunity to interact with